All right, so we're going to identify horizontal and vertical asymptotes. All right, for vertical asymptotes, okay, that comes from the denominator. Okay, so in this case, we're going to say x squared plus 5 equals 0. In this particular case, for our vertical asymptotes, there are none, because vertical asymptotes, if I was to solve for x, okay, I'd get x squared equals a negative 5 square root of both sides, and we do not deal with negative square roots. So this does not have a vertical asymptote. Right here, you will take your denominator and you will set it equal to 0. It's the same as our restrictions, like when we started in the beginning of the semester. I'm going to factor it, because I'm never going to use quadratic if I don't have to. X plus 5, x minus 2 equals 0. So here my x is equal to a negative 5. That's one of them. X is equal to 2. That's another one. So this one had 2 vertical asymptotes. This one right here. Oops. We're going to do all our vertical ones first, as you can tell, or hopefully you can tell. Right here, again, I'm going to factor. Now you can use quadratic formula if you want. I just personally think it takes longer. Okay, this is going to factor as 2x and x, and this is going to be my minus 5 and my plus 1. Okay, you take both of these, set them equal to 0. You would add 5 to the other side and divide by 2, and you get x equals 5 halves, or 2.5. That's one of them. Here you just take x plus 1, set it equal to 0, subtract 1, and you get x equals negative 1. So you have this one as well. Okay, and this one right here, all you have to do for your vertical asymptote is take your denominator, set it equal to 0, add 4 to the other side, and you get 3x equals 4. Now you divide by 3, and you get x equals 4/3. So you'll have 1 vertical asymptote. Okay, horizontal asymptotes. These you have to compare the degrees. Of numerator and denominator. Okay, so you have 3 cases. You have the numerator degree is less than the denominator degree. If that's the case, y is equal to 0. You have the numerator degree is equal to the denominator degree, and that's the case, you'd put the leading coefficient of the numerator over the leading coefficient of the denominator. And then the last one, your numerator degree is greater than the denominator degree. In this case, there is no horizontal asymptote. Okay, so what we're going to do is we're going to compare our degrees. Well, this one has a degree of 0. This has a degree of 2. So this means that let me put horizontal asymptote. That means the numerator degree is less than the denominator degree. So our horizontal asymptote is y equals 0. It's right there. Okay. I don't think I'm going to write this every single time, because if you look at my notes or the answers, I have written them, but I've got it right here and I'm explaining it. So, all right here, horizontal asymptote. This has a degree of 4. The denominator has a degree of 2. So the numerator degree is greater than the denominator degree. So there are no horizontal asymptotes. Numerator degree for C is 2. Denominator degree is 2. Okay? So that means they're equal. That means you're going to put the leading coefficient of the numerator. The leading coefficient here is a 1 over the leading coefficient of the denominator, which is 2. So there's where your horizontal asymptote is. And right here, degree of 1, degree of 1, they are equal. Again, when they are equal, leading coefficient of the numerator, which is 2, over the leading coefficient of the denominator, which is 3. And again, these are imaginary lines, so you have to have the y equals. That is a horizontal line at 1/2, a horizontal line at 2/3. Okay, these are vertical lines. They're imaginary vertical lines. Okay, so make sure you have both of them. This is bugging me. I'm just going to put it like that because I did all these down here. That one. All right. This one right here, these should not be really that hard. Okay? This just means you're going to take function f and add it to function g. So you're going x plus 4 plus x squared plus 3x minus 1, and combine your like terms. I'm going to start with my x squared. I have x and 3x, which gives me 4x. 4 minus 1 gives me 3. Just be careful on subtraction. Okay, be careful. You're going to take your f, which is x plus 4, and you're going to subtract your g, which is x squared plus 3x minus 1. The reason I say be really careful is because when you have a minus sign, all the signs change. Like this x plus 4 stays the same. This x squared becomes negative. The 3x becomes negative. And the negative 1 becomes positive. And why that happens, I mean, there's a couple of things. I just say change all the signs. If you want, you can just distribute the negative, or you can distribute a negative 1. And then you're going to get that same thing. Now you're going to combine your like terms. So we have negative x squared. I have a positive x and a negative 3x. That's really a 1 in front of it. So I get negative 2x. And then I have 4 plus 1. That gives me 5. Okay. This means multiplication. So I am going to say x plus 4 times x squared plus 3x minus 1. So what I'm going to do, I can't really use FOIL because you only use FOIL with binomials times binomials. But so that's why I don't really like the word FOIL, but you're going to take this x and multiply by everything inside the other parentheses. So x times x squared is x cubed, x times 3x is 3x squared, and x times a negative 1 is negative 1x, or just negative x. Now I'm going to take the 4 and multiply it by everything inside the other parentheses. 4 times x is 4x squared. 4 times 3x gives me 12x. And 4 times negative 1 is negative 4. Now I'm going to combine my like terms where I can. So I don't have an x cubed, so I'll just bring it over. I don't have, oops, did I miss, oh, I hope I missed this. X times 3x is 3x squared. Sorry. I thought I missed something. 3x and 4x gives me 7x squared. Let's try that again. 3x squared plus 4x gives me 7x squared. And now I'm going to have negative x and a positive 12x gives me positive 11x. And then I don't have anything that goes with the minus 4, so I'm just going to bring it over. And then that is my whole answer. Okay. Now, these open circles do not mean multiplication. This means it's a composition. You are going to take your g. It's f of g of x, where g of x is going to be our x. So you're going to take your g and you're going to plug it in for f. So I have my f right here. That is my f. I am going to take this whole thing and plug it in where I see an x. The x squared plus 3x minus 1 is going to go right there. So I have my x plus 4. And in this case, it's going to be this whole thing goes right there. So it's really x squared plus 3x minus 1. And then I have plus 4. So now I'm just going to rewrite it. X squared plus 3x. I have minus 1 and plus 4 gives me plus 3. Okay. Right now, let me erase this. So grateful for erasable pens. I only used pencil before. Because as you know, I make mistakes. I wish I didn't, but okay, I'm going to take my f now, and I'm going to plug it into g. So that means I'm going to take this, and wherever I see an x, I'm going to substitute x plus 4. So I have, for this problem here, whatever x is, I'm going to square it, plus 3 times whatever my x is, minus 1. In this case, I'm taking this and plugging it in, so I really have x plus 4 squared, plus 3 times x plus 4, minus 1. Okay. So that's the first obstacle. The second obstacle is this right here. I know the shortcut, so I'm going to do the shortcut. It is x squared plus 8x plus 16. I'm going to distribute this, and I get plus 3x plus 12 minus 1. Guys, if you do not know how I get from here to here, then you are going to say x plus 4 times x plus 4, and you're going to use FOIL to come up with this. So now I'm going to combine my like terms. I have x squared. 8x and 3x gives me 11x. 16 and 12 gives us 28, and negative 1 gives us 27. And this one right here. I know this is weird, but you're going to take your f and you're going to plug it into f. So my f looks like this. It's some value x plus 4. In this case, it's going to be x plus 4. See, I can rewrite this as f of x, okay, where my f of x is x plus 4. Well, this is telling you that is my x. So x is equal to x plus 4. So that when I have the function of x plus 4, that means I'm going to take this out and replace it with that. And that's where I get this. So now I have x plus 8. because that and that.